Today we are going to discuss about interrupt of 8051. We know that an interrupt is an external or an internal signal to the processor architecture that temporarily changes the flow of execution of the main program. It may execute another program before continuing with the main program. That is, an interrupt is mainly used for data transfer, where an external device informs the CPU that it is ready for communication and requests the attention. This process is a asynchronous process, which means that it can be initiated at any time without the reference to the system clock. The interrupt are events which are interrupt the normal program execution. In this 8051, it provides the illusion of multitasking. Although in reality, the 8051 is only doing one thing at a time. Whenever any device needs its service, the device notifies the microcontroller by sending it an interrupt signal. Here, the steps on interrupts are as follows. This is the microcontroller and this is the external device. This is microcontroller and this is the external device. If the external device needs to transfer a data, then it sends a signal, interrupt signal to the microcontroller to inform that it is ready for communication. Then the interrupt is initiated and here the microprocessor normal execution is halt or temporarily stopped, and it executes the program that is given by this external devices. That process is known as, or procedure is known as, interrupt service routine or interrupt handling routine. So microcontroller currently stop its current execution of the current instruction and it execute the interrupt service routine. After the completion of this interrupt service routine, the normal program execution starts from where it was interrupted. So this is the main program. When an interrupt occur this location, so process stop the execution of this complete the execution of this current instruction, and it will be transferred to the interrupt service routine, and it starts the execution of interrupt service routine. After the completion of this interrupt service routine, the program control will be transferred to the main program and its execution begins from where it is interrupted. And there are total 5 interrupt sources in 8051. So 8051 architecture supports total 5 interrupts. Out of these 5 interrupts, 2 interrupts, namely INT0 and INT1, and external hardware active low interrupts. They can be enabled and programmed using the least significant 4-bit of TCON register and interrupt enable and priority registers. The remaining 3 interrupts, they are internal interrupts, timer 0 overflow, timer 1 overflow, and serial transmission and reception interrupt. These are the 3 internal interrupts and the 2 external interrupts are there. Total 5 interrupts are interrupt source in 8051. When the 8051 is powered up, the priority are assigned according to the following. In reality, the priority scheme is nothing but an internal polling scheme. sequence in which the 8051 polls the interrupt in this sequence. Here the highest priority is given to external interrupt 0, that is INT 0. Then second priority is timer interrupt 0, then is external interrupt 1, then timer interrupt 1, and the least priority is serial communication, that is receive interrupt and transmit interrupts. So its corresponding address is shown here. Internal interrupts is address is 0003H, and timer or counter 0 is address is 000BH, and external interrupts it has 0013, and timer 1 has 001B, and serial port has 0023. This is the address of the corresponding interrupts. The interrupt 0, 1, 2, 3, 4, that is total 5 interrupts are there. 2 external interrupts INT 0 and INT 1, and 3 internal interrupts timer 0, timer 1, and serial port. In 8051 support two types of interrupt registers. First one is IE, that is interrupt enable register, and another one is interrupt. The interrupt enable register is an SFR register and mainly used to enable interrupts. The MSB bit 7 is used to disable all the interrupts. So here this is a interrupt enable register. Here there is a EA. The 7th bit is here EA. It disables all the interrupt, and if EA is equal to 0, no interrupt will be acknowledged. That means it disables all the interrupt. And if EA is equal to 1, then the interrupt source is individually enabled or disabled by setting or clearing the is enabled bit. So here there is a ES, enable or disable the serial port interrupt. S indicate serial port interrupt. ET1, that enable or disable the timer 1. T1 indicate the timer 1 overflow interrupt. EX1, that is it enable or disable external interrupt 1. And ET0 is enable or disable the timer 0 overflow, and EX0 is EX indicate external interrupt 0, that is enable or disable the external interrupt. Then second one is interrupt priority register. The interrupt priority register specify the relative priority, high or low priority of each interrupt. And 8051, an interrupt may be either of low or priority or higher priority. Low priority is indicated by 0 and higher priority is indicated by 1. So 8051 provides with 5 interrupts, and timer 0 overflow it indicated by TF0 in the TCON, and it is being set. And timer 1 overflow it indicates by the flag TF1 in TCON and being set. And serial port event interrupts are there. And here this is the priority interrupts, and here the priority bit 1 assigns high and higher priority, and bit 0 assigns lower priority. Here the first bits IP7 and IP6 are reserved, and IP2 it is timer 2 interrupt priority. It is not used in 8051. Next is PS for serial port interrupt priority, and PT1 is timer 1 interrupt priority, and PX1 is external interrupt 1 priority, and PT0 It is timer 0 interrupt priority bit, and PX0 here external interrupt 0 priority bits. So these are the two registers used in the